of the convergence of the power series is, so for option associated to interval of convergence is given, and we have to select right one option. As you can see, this series is alternative positive and negative, and n is running from 1 to infinity. So when n is even, then it is positive term series, and when n is negative, then it is a negative term. So alternative positive and negative terms will appear in the expansion of this series. So this series is of the format n equal to 1 to infinity 1 upon minus 3 raised to the power n plus 2 4x minus 12 raised to the power n divided by n square plus 1. So the standard format of the power series an x minus x naught raised to the power n. So given series it not look like in standard format. So first our aim is to find interval of convergence to reduce this given series into the standard format of the series if it is possible. Otherwise we will move with other technique to solve this problem. So we can do this by taking 4 as a common. So n equal to 1 to infinity 1 upon minus 3 raised to the power n plus 2, and 4 I took as a common, x minus 3 raised to the power n, and 4 raised to the power n will be here. So it is n square plus 1. So I write this series, reduced series in good looking form. So this is n equal to 1 to infinity 4 raised to the power n minus 3 raised to the power n plus 2, and n square plus 1, and this is x minus 3 raised to the power n. So this will play the role of x minus x naught raised to the power n, and this will play the role of an. So series can be considered in the standard format an x minus x naught raised to the power n. When series in standard format, so we can find radius of interval with the help of an divided by an plus 1, and we need to check limit of this expression. I took a mod or absolute of the absolute function of this term because of series is alternative positive and negative term, means terms of this series. Whenever series is positive term series, means entirely positive term series, then there is no need to put a modulus value. So with the help of this we can find the radius of the convergence, and interval of convergence is more precise way to say convergence of the power series, because of within the radius of convergence series at the boundary points may or may not be convergent. But whenever we have the interval of convergence, means we have the domain where we can say that given series is convergent or not. So first is we are estimating, means convergence by the radius of convergence. So we are trying to find radius of convergence with the help of explain terminology or technique. So limit, it will be r radius of convergence, limit n tends to infinity 4 raised to the power n minus 3 raised to the power n plus 2 and n square plus 1. This is the value of an, and when we put the value of an plus 1, means minus 3 raised to the power n plus 3, n plus 3, and within bracket n plus 1 square plus 1. So it will be the value of this, and in denominator it will be 4 raised to the power n plus 1. So by this it will cancel out and 4 will remains here, and you can see one power is extra, so minus 3 will remain here. So the expression we get, limit n tends to infinity, and also we need to take or put a modulus. So minus 3 upon 4 I can write, and in numerator part if I expanded this, n square plus 1 plus 2n plus 1 divided by n square plus 1. We have this expression and we need to check limit. So because of mod is put it here, so I can write directly 3 by 4, and after taking n square in numerator and denominator, n square will cancel out, and after putting limit directly, we have 1 in numerator and 1 in denominator. So finally this is the limit, or I can say this is the radius of the convergence. Or in other terminology, you can consider this is a polynomial in numerator and polynomial in denominator. So higher power coefficient of higher power term is 1, and coefficient in denominator higher power term is again 1. So 1 by 1 is the limit of this expression as I marked red. So radius of convergence of this series is 3 by 4. It means that x minus 3, or mod of x minus 3, is less than 3 by 4, and I can solve this by minus 3 by 4 x minus 3 is greater and less than 3 by 4. So I can add 3 to this inequality. So what we have, 4 3 is 12 minus 3, 9 by 4 less than x less than 3 4 is 12, 15 by 4. So this is the interval of convergence, means 9 by 4, 9 by 4 less than x less than 15 by 4. So in first option you can see that 10 by 4 is 10 by 4 is greater than 9 by 4. 10 by 4 is greater than 9 by 4. So option A discard, because it is going outside from the radius of convergence. So option A discard here, and in option C same reasoning here. So option A and C both discard. So correct possibility of correct options may be B or D. So in B and D you can see 15 by 4 in right hand side of the inequality, and equality hold over 15 by 4. So one option will be discard automatically if we check convergence of this series at 15 by 4. So we need to check convergence of this series at 15 by 4. So this is the given series is this. So I'm taking this expression again, and we need to check convergence of the given series at 15 by 4. So put x equal to 15 by 4 in the given series, and what we have, so this will be 15 by 4, and it will be 3 raised to the power n minus 3 raised to the power n plus 2 n square plus 1. So this is the series and is running from 1 to infinity we obtained after putting x equal to 15 by 4. So you can say this is alternating series, and for alternating series we can apply Leibniz test, because you can see if I consider this is the term an, so after making positive term series, means we can write this series as 3 raised to the power n minus 1 raised to the power n, because of negative sign will depends on n. If n is even, then positive sign will appear, means positive terms will appear. If n is odd, then negative terms will appear. So minus 1 raised to the power n I took in numerator, and minus I can put positive sign here, n plus 2, and in another bracket n square plus 1. So this is the other way of writing, or you can say simpler form to apply Leibniz rule here. So after making positive term series, we can say un is 3 raised to the power n divided by 3 raised to the power n plus 2, n square plus 1. So as we increasing n, as we increasing n, so denominator part will increasing faster than numerator part, means denominator part will increase faster than numerator part, so it is a decreasing series. Oh, sorry, decreasing, this is a decreasing sequence you can say. And limit of this sequence we need to check or term. So what is the limit? It is decreasing, it is understood, and we need to check limit at infinity. 3 raised to the power n divided by 3 raised to the power n plus 2, n square plus 1. So this one will cancel out and we have 3 square in denominator. So 1 upon 9 n square plus 1. After putting limit n tends to infinity, we will got this limit tends to 0. So both condition of the Leibniz test is satisfied, so this series is convergent at 15 by 4, means 15 by 4 is the point of convergence, so option D is correct.